So in this video, we're going to talk about exponential properties. So before we go on to discuss these, I've seen these explained many different ways. However, there are some ways I feel that are more effective than others. First of all, just a brief description here. We have this value of x here, and I'm going to assume that this is called the base, and we all should be able to recognize that this is called the base. That exponent there is a value that I called m, and this is the exponent. So exponent. So we have x to the m. So if it's not present, we know it to be a value of 1. So in this circumstance, if it is not present, this is the same thing as me saying x to the first power. So when we talk about these properties, I'm going to assume this value of x could be anything. It could be a constant, but if it's a constant, we have to assume that constant is greater than 0 for all these properties to apply. So sometimes you might see the term a to the x power, or you might see the term times a to the y power. So sometimes you might see these interpolated where your bases are labeled differently. However, I just want to make sure that we know that if it's a variable, that variable I will label as x, and if it's a constant non-variable, I'll probably label that an a. So keep that in mind. But the base will have to be positive for all these rules to apply. That doesn't mean it has to be positive to perform the operations, but for these specific rules to apply, we want to assume the base to be positive. So let's go ahead and talk about our first property. Our first property that deals with exponents is that we're going to call this the multiplicative property. So let's go ahead and talk about the multiplicative property. So if we are multiplying similar bases, we add their exponents. So if we're multiplying similar bases, we add their exponents. So let's just look at a nice, relatively easy example. If I give you x cubed times x to the 7th, this gives you x to the 3 plus 7 power, and that is x to the 10th. So I think that's relatively an easy one for us to remember. Nothing too complex. So that gives you a value of x to the 3 plus 7, which gives you a value of 10. So this also could be applied to a constant. So if I have 2 cubed times 2 to the 6th power, this will give me 2 to the 9th. So this can apply the same exact way. So keep that in mind, but notice here my base is a positive 2. These are positive 2s, so that's why I'm not doing very well here with my writing. That is why this can be applied in such a fashion. So a positive 2 and a positive 2. All raised to those exponents, you can add their exponents. So that right there is pretty straightforward. So now let's talk about our quotient property. And I'm sure most of you can even guess what this is that if we have two bases raised to an exponent and we are dividing them, and their exponents, m and n, are integers, or they could be any values. They don't have to be integers. They could be any real number, we'll assume, other than 0. This will give us a value of x to the m minus n power. So we will assume n comma m do not equal to 0. So we're going to assume they don't equal to 0. But otherwise, this holds true in any other circumstance. So let's go ahead and try an example here. So if we have y to the 4th power all over y to the, 3rd power, this gives us y to the 4 minus 3, which gives us y to the 1st power, or y. And this is the same thing as saying y to the 1st power. So either one of those work well. And I'm sure when you see it written like this, I'm sure you're starting to think, what happens if my exponent's negative? And that's going to be another property we're going to discuss shortly. And again, I'm rapidly going through these just to quickly surmise them. And I'm not going into too many examples. I just want to make sure we emphasize these properties. So now let us talk about, let's go ahead and talk about the power. Let's talk about the power rule. So if I have a base, I'll call this x, and it is raised to the nth power, and I'm raising this to the nth power. So this means that I will multiply my exponents. And the way that I think about memorizing this is that I think, okay, I'm raising one to the other. One's higher than the other. The n is slightly higher than the mth. And if we think about this, if I had x to the m times x to the nth. These two, I think, are an equal playing field. So equal playing fields, I think I'm adding. However, if one is higher than the other, for some reason, that screams to me multiplication. So that helps me memorize the power rule of the exponent property. So let's go ahead and try this out. If I give you x cubed raised to the 4th power, think about this. This really means x to the 3rd multiplied out 4 times. So 3 plus 3 plus 3 plus 3, I'm multiplying all these bases, so I add them and I get x to the 12th. And notice 3 times 4 also gives you that value of 12. So the power rule is a very important rule that we will use quite frequently in any math science course. So these next rules I'm going to sort of combine. I'm going to call them power of the product quotient rule. So if I have x to the mth times y to the mth all over, I'm going to say z to the mth. And x, y, and z are all variables. These are all variables. They could be a's. They could be, well, according to us, so they could be x, y, z. It could be anything we want. They're all variables. So if I am raising these all to another exponent, I want you just to sort of think, I don't want to say distribute, but I'm going to use that term loosely here. But in essence, this n has to be distributed, and I'm going to use that term loosely, to every single variable in this and its exponent. So that's sort of the power of the product rule. The product rule right here is this guy, and the quotient rule is the division portion. So I'm sort of combining this. So basically all this says is to make sure that you multiply the n times this m, the n times this m, and the n times this m. So this, in actuality, will be x to the mn power, m times n, times y to the m times n power, all over z to the m times n power. So we want to make sure that we multiply or distribute this exponent to every single base, and we're raising it, so we're going to multiply our exponents together. So let's go ahead and try an example out and see how we do. Let's go ahead and try an example out and see how we do. Let's say we have x squared y cubed all over z to the 4th, and I'm going to raise this all to the 5th power. So what does that mean? This 5 has to be multiplied by this 2. So that's going to give us x to the 2 times 5 power, which gives us a value of 10. This 5 must be multiplied by the 3. This is the product rule portion of it. So that gives us 3 times 5, which gives us y to the 15th. All over. The the 5 must be multiplied to the 4. So this will give us z to the 20th. So that's what happens when we are multiplying multiple bases and dividing them simultaneously, all raised to an exponent. Okay, so let's go ahead and continue. Let us talk about our next property, which is negative exponent property. This just states if we have a negative exponent, we just take it and flip it all over 1. So if we want to make a negative exponent positive, we take it and flip it over 1. So this also holds true if that negative exponent's on the bottom. Let's see why. If I have this, I'm really dividing it by by the positive exponent. So that's x raised to the positive n. So the ones here would cancel. This flips up on top, and that will give us x to the positive m power. So if you have a negative exponent, either bring it to the bottom or bring it to the top, and that will get rid of the negative. It negates the negative value. So let's go ahead and try exemplifying this. Let's go ahead and try an example of x to the 4th power divided by x to the 7th power. Hopefully you recognize here that we're using a quotient rule. So we're going to have x to the 4 minus 7 power. We're subtracting our exponents, and this gives us a value of x to the minus 3. But it's sort of bad grammar to leave negative exponents. We don't ever want to leave negative exponents. So if we want to make this positive, we are going to bring this over a value of 1 and make the exponent positive. Let's go ahead and try another example. Let us say we have a to the 4th power, b to the 7th power, all over a to the 2nd power, b to the 12th power. So working through this, we recognize that we have to evaluate these a's first. So I'm going to evaluate my a's first. So this gives me, I like to write out my steps to make sure I don't make any mistakes. 4 minus 2 power. Then I will evaluate, where are my b's? I will evaluate my b's here. My b's. So this will give me b to the 7 minus 12 power. So now this will give me a to the second power, and then 7 minus 12. Okay, we think, okay, 7 minus 12, that's going to be negative. So we will write the negative exponent. I will write the negative exponent up here on top. So I will write this as b to the negative 5, because 7 minus 12 gives you a value of negative 5. And then I will take the next step to simplify this, because I don't want to leave this negative exponent attached to the b up on top. So I'm going to bring it down to the denominator and say this is b to the positive 5th power. So now we have simplified this completely, and it doesn't have any negative exponents, which is sort of the proper math grammar. So be very confident in your abilities to manipulate negative exponents, but that's going to come through a little bit of practice. So definitely practice the negative exponents consistently. Let's go ahead and talk about our zero exponent property. Zero exponent property. Our zero exponent property states that anything raised to the 0 power is always equal to 1. And that makes it very simple. I don't even know myself as to why this is true. This is something that I've just been told for a very long time, so I believe it to be true. So if any of you write to me saying, why is this true, I really don't know the answer. I guess I could research it myself, but I have just been very confident that everyone that's told me that anything to the 0 power is always 1, so I believe it to be true. So if I look at example 2x to the 4th, y to the 5th, all raised to the 0 power, this in fact will all be 1. Relatively nice example. Be careful to watch out for your order of operations. Negative 2 to the 0 power. Many people may think that this is a value of 1, but if they believe that, they would be incorrect. Negative 2 to the 0 power is really going to be careful, this exponent 0 is attached solely to the base 2. So here we recognize this will be a value of negative 1. So be very careful about this. We don't want to make this mistake, and that's an order of operations issue. So make sure to practice this out several times to not make that mistake, because you will see it come up consistently in class. So we never ever want to miss that. Be very careful. Most of the times when we use the zero exponent property, it tends to be very nice and it works out very well. Those are a summary of your properties, so make sure to practice them out through some examples, and wish you the best of luck.